Hi everyone. So today we're going to start off with our new section on trig integrals. Just before we get started, I just want to make a little note of the things that you need to know before you get to this chapter. So please go over, and it's just a few things. So number one, your trig identities. So, your half angle formula, your double angle formula, sine squared plus cos squared is 1, the one with tan squared and sec squared and so on. So just your trig identities in general. Number two, your trig derivatives. Okay, so your derivative of sine, cos, tan, cotan, all of those. And number three, U-Substitution. Okay, so all three of these go into trig integrals. Okay, so please make sure that you revise these three before going through with these problems. Okay, so today's lecture is just going to be on the idea of solving these trig integrals and various methods that you can use. Okay, so there will be quite a few methods that we need to go through. We'll start off slowly and then build up as we go through. Okay, so let's get started with the first example. And as always, please just stop me if if you're confused with anything while we're going through. Okay, so example number one. Okay, so we want to evaluate the integral of cos cubed x dx. Okay, now we can't use any of the standard integral techniques that we've seen. You can't use the power rule, we can't use U-Substitution here, we can't use integration by parts, we're kind of stuck. So what we do is we notice the relationship between cos and sine. So remember that identity cos squared x plus sine squared x is equal to 1. Okay, in other words, we can write cos in terms of sine and we can write sine in terms of cos using this. So what we're going to do is rewrite cos squared as 1 minus sine squared. Okay, that's the idea here. So we're going to take one of the cos terms, because we've got three of them. We've got three here. One of them we're going to factor out. So we're left with the integral of cos squared x times cos x dx. Okay, so we factor this term out. Okay, what we do next is this cos squared we're going to rewrite in terms of sine using this that we found in red. So this part over here, we're going to substitute into there. Okay, so this is going to give us the integral of 1 minus sine squared. Okay, so we replaced cos squared with 1 minus sine squared, cos x dx. Okay, so that was just using that trig identity to write it like this. Now, why did we do that? Well, notice that over here we have a sine term. Okay, 1 minus sine squared, it's some function of sine. And what do we have on the outside? We have cos x dx. Okay, so what's the relationship between this function of sine and this cos x dx here? What can we do to simplify this? Any ideas? So what do you think we should do? We've got 1 minus sine squared, and then outside we have cos x dx. What does that remind you of? Think about the relationship between sine and cosine. Yeah, anyone? Okay, so you should be thinking to yourself that you can do a U-substitution, because if we let U be equal to sine x, then du is going to be cos x dx, which is exactly what we've got in green. So if we let u be sine x, then the derivative is this outside part in green. So we can replace this integral using our u substitution with 1 minus u squared du. Now this is easy to do. Okay. So this is the core idea of trig integrals. You need to use a trig identity to rewrite the integral such that you can use a u substitution. Okay, this is the very important part over here. Okay, so you rewrite your integral using a trig identity so that you can make a u substitution. Once you've made the u substitution, then it becomes very easy to do. Okay, so let's put a big star over here. This is the main idea of trig integrals, is to do this part. Okay, if you can handle that, the rest is just power rules and stuff like that. Okay, so what does this become? This becomes u minus 1/3 u cubed plus c. Okay, but we're not done yet because we've got u, but we want it in terms of x. So we replace u with sine x. So this will become sine x minus 1/3 sine cubed x plus c. Yeah, and that's our final answer there. Okay, so we see that in this case, so this is, think of it as your first case dealing with trig integrals. If you have cos to an odd power, so we have cos kx, where k is odd. So if it's odd, we can factor out a cos x. Factor out cos x, so that we have cos x dx on the side. Okay, so that's your step 1. Okay, so we can call that step 1. Step 2, rewrites everything else in terms of sine. Okay, so how do we do that? Well, if k is odd and we factor out a cos, then the remaining term will be even. So if it's cos cubed and we take out a cos, we're left with cos squared. If it's cos to the 5 and we take out a cos, we're left with cos to the 4. In all of those cases, you're left with an even power of cos. So what we can do is we can say cos squared of x is equal to 1 minus sine squared x. So if it's cos squared, you write it like this. If it's cos to the 4th power, what do we do? It's going to be cos to the 4th power of x will then be 1 minus sine squared x, all of that squared. Okay. Yeah, so it's always an even power of cos because we factored out a cos x. Okay, so that's step 2. Step 3, make the u substitution of u equals sine x. Okay, so we wrote everything else in terms of sine, so that tells us that our u substitution needs to be u equals sine x. Okay, step 4. Integrate in terms of u. Okay, so we've done the U substitution. Now we can do the integral in terms of U. And finally, the last step, sub U equals sine X back to get everything in terms of X. Okay, so that is our guide. Okay, so we can take this as general. So if you have an odd power of cos, we follow these steps. Okay, so if this cos to the kx appears where it's odd, then you follow these steps, and that's how you solve those types of problems. Okay, any questions so far? Okay, let's take a look at the next case. Okay, so this is example number 2. So we have the integral of sine to the power of x cos squared x dx. Okay, so we want to try and figure this out. Now we see that the power of sine is odd. Okay, so we've got sine x to the power 5. So that gives us the clue as to what we need to factor out. So sine is odd. We've got an odd power of sine. So that means we factor out one of the sines. So this is going to be equal to the integral sine to the 4x, because we took one out, cos squared x sine x dx. So let's just put that in green. That's on the outside now. Okay, so we're done with that. That's separated out. We can leave that alone. Okay, so since the outside part is sine, what kind of U substitution do we need to do? So if this part is our du, we want that to be du. What does U have to be? So I want to derive something to get sine. What does it have to be?
So would it be cos?
Yes, yeah, we would need something with cos. So what we need to do is take this part over here and write it in terms of cos. So write this in terms of cos. Okay, so if we write all of that in terms of cos, then the derivative will give me this du part on the side. Okay, so cos squared, that's already in terms of cos, but we need to handle the sine to the 4. How do we deal with that? Well, we use our trig identity. Remember, cos squared x plus sine squared x is equal to 1. Sine squared x is equal to 1 minus cos squared x. But we want sine to the power 4. So sine to the power 4 of x is going to be 1 minus cos squared x squared. Now this can then be substituted. So let's do that. So this is going to be the integral of sine to the power 4. We need to write in terms of cos, so we do that. 1 minus cos squared x, all of that squared. Then we have another cos squared x. And finally, we have sine x dx. Okay, and I'm going to leave that in green because we want that to be our du. Okay, good. So we've written everything in terms of cos, and we've got this term on the side, which we want to be du. So now we can make our U substitution. So U is equal to cos x, like you said. So du is going to be the derivative of cos, which is minus sine x. Okay, but we don't want minus sine x, we just want sine x. So we take the minus to the other side. So minus du is sine x dx. Okay, which is what we wanted in that green part. Okay, so now let's just substitute everything. So we're going to have the integral 1 minus cos squared will become 1 minus u squared, all of that squared. Cos squared will just be u squared, and sine x dx will become minus du. Okay, so that's after the u substitution. Okay, are there any questions about that? Okay, so let's simplify this and then we can integrate. So this minus we can take out. So it will be minus the integral 1 minus u squared, all of that squared, times u squared du. Okay, I've just got a question here. Why did we make it cos from the beginning? We made it cos because the power of sine is odd over here. So if we go back to the previous example, we saw that cos has an odd power. So we factor out cos. Okay, so we had cos to the power 3. We took out one of the cos terms. Now in this case, we have sine to the power 5. So sine to an odd power. So we take out a factor of sine. Okay, it's always like that. Whatever has the odd power, you factor out, and then everything else, you turn into the other trig function. So let's just go back to this one. So we took out a cos, so everything else now needs to become sine. In this case, we took out sine, so everything else now needs to become cos. Okay, it's always those two going hand in hand. Okay, so whatever the odd power is, you factor that out. Whatever's left over, you change to the other trig function. Okay, in this case, the leftover part was sine x, sine to the 4x. We need to change all of that to cos. Okay, does that answer your question? Okay, cool. Okay, so after that, we do our U-substitution. Now we need to figure out this over here. Okay, but that's not too bad. We can just use some expanding, and then we can use the power rule. So if we expand this first bracket here, because it's all of that squared, this is going to give us 1 minus 2u squared plus u to the 4. And then don't forget the u squared over there. Okay, so what we need to do now is multiply in the u squared. So this is going to be minus the integral u squared minus 2u to the 4 plus u to the 6 du. Okay, so I just distributed that inside. Okay, so what we need to do now is just integrate. So we have minus 1/3 u cubed minus 2 over 5 u to the 5 plus 1 over 7 u to the 7. Okay, and then I'm just putting in brackets because remember we've got this minus sign in front. Okay, so we need to remember that minus sign there, and then plus c. Okay, so here we're going to have minus 1/3 u cubed plus 2/5 u to the 5 minus 1 over 7 u to the 7 plus c. Okay, but we're not done yet. We need to put this back. So u was originally cos x. So we need to substitute that. So this is going to be minus 1 over 3 cos cubed x plus 2/5 cos to the 5x minus 1 over 7 cos to the 7x plus c. Okay, so remember to always substitute back when you're done. Okay, any questions on this one? Okay, so this is the procedure when sine has an odd power. If it has an odd power, you take out a factor of sine, you turn everything else into cos, and then you do the U-substitution of u equals cos x. Okay, so everything has to do with this U-substitution. Okay, so trig integrals are just a very special case of U-substitution. Okay, so there's nothing special about this. You just need to know how to manipulate it and then what substitution to make. Okay, someone's asking to re-explain. Yeah, sure, we can do that. So let's just take a look at this example again. Okay, so we had, it was the integral of sine to the 5x cos squared x. Okay, so when you're given this question, the first thing that you need to notice is that the power of sine is odd. Okay, it's an odd power of sine. Okay, so odd power of sine. Okay, so what happens, what do we do if it's an odd power of sine? The first thing we need to do is factor out one of the sine x. Factor out sine x. Okay, because it was odd, we took out one of the sine x, the remaining part will then be even. So what does this give us? It gives us the integral sine to the 4x cos squared x. I'll put this in brackets to show you that it's separate, sine x dx. Okay, I took out the sine. Okay, so we're done with that. Okay, so we took out sine. That means we need to change everything else to cos. So change everything else to cos. Okay, so we took out sine, change everything else to cos. So that's exactly what we're going to do. Everything here in blue, the stuff in blue, we need to change to only cos. So how do we do that? Well, sine to the 4x we need to make into cos. So remember, sine squared x plus cos squared x is equal to 1. Sine squared x is equal to 1 minus cos squared x. Sine to the 4x is 1 minus cos squared x squared. Okay, that's the key idea here. So we're going to take the sine to the 4x and replace it with this cos equivalent. So let's do that. So we have the integral. Please stop me whenever you're lost on the steps here. Okay, so I don't want to get too far with everyone being confused. So sine to the 4x, we replace with the cos equivalent over here. So that's going to be 1 minus cos squared x squared. And remember, we still had that cos squared x on the side. And this sine x dx on the outside. That's done. Now, we changed everything to cos. So that tells us what the U-substitution needs to be. Okay, so everything else was changed to cos x. So let u be equal to cos x. If we made everything cos x, that's exactly what the u substitution needs to be for here and here. Okay, so we do that. What's du going to be? Du is going to be minus sine x dx. We don't want minus sine x dx. We want sine x dx. There's a minus sign in our way. So we take the minus across. So we have minus du is equal to sine x dx. And that's what we want. Okay, we want that to go over there. So let's do the u substitution. This is going to be the integral of 1 minus cos squared is going to be 1 minus u squared. But all of that was squared, so all of this is squared. Cos squared becomes u squared. Sine x dx becomes minus du. Okay, so that's the end of the u substitution now. So we just need to evaluate this integral. So we take the minus outside. Then we have the integral of 1 minus u squared, all of that squared, u squared du. Okay, equals, that's going to be minus the integral 1 minus u squared, all of that squared, is going to be 1 minus 2u squared plus u to the 4 times u squared du. Okay, now we need to distribute the u squared inside. So this is going to become minus the integral u squared minus 2u to the 4 plus u to the 6 du. Okay, so I just multiplied that inside. So what's the next thing that we do? We integrate. So this is going to be minus 1/3 u cubed minus 2/5 u to the 5 plus 1/7 u to the 7 plus c. Okay, so let's distribute the minus. We're going to have minus 1/3 u cubed plus 2/5 u to the 5 minus 1/7 u to the 7 plus c. Okay, but we're not done yet. We don't want things in terms of u. We want things in terms of x. So we go back all the way here. U is equal to cos x. So let's put that in. So this is going to be minus 1/3 cos cubed x plus 2/5 cos to the 5x minus 1/7 cos to the 7x plus c. Okay, that's the last step that we need to do. Okay. Any questions so far? Is that all right? Okay, sure, no worries. Okay, let's move on to one more. Okay, so I'll just start off this problem and then I will put up the homework problems. Okay, so we dealt with what happens when sine is even, and we dealt, when sine was odd and when cos was odd. Those are done now. So next we need to look at what happens when sine is even and cos is even. What happens if they're both even like that? So let's start off with a simple example. The integral of sine squared x. Okay, how do we handle something like this? This is a very nice special case because sine squared, if it's just to the power 2, we can rewrite this using the half angle formula. So this is equal to the integral of 1/2 of 1 minus If it's sine, we put a minus. If it's cos, we put a plus. So minus cos 2x dx. Okay, so we've met this before. Okay, but now we're treating it as a trig integral. Okay, so the half we can take out. And we're left with the integral of 1 minus cos 2x dx. Okay, now we don't have to do any use substitution now. So you see this is a very nice special case. So just integrating this, we get 1/2 x minus 1/2 sine 2x plus c. Okay, and then we can distribute the half if you want to. We can write this as 1/2 x minus 1/4 sine 2x plus c. Okay, so you see it's very nice if we just have sine squared. Now, if we have cos squared, let's just do that on the side here. What do we do in this case? This will be the integral of 1/2. This is also another special case when it's just cos squared. It's going to be 1 plus cos 2x dx. So we take out the half, and we have to integrate 1 plus cos 2x dx. So we end up with 1/2, 1/2 x plus 1/2 sine 2x plus c. And then we can distribute the half if you want to. You can have 1/2 x plus 1/4 sine 2x plus c. So in these two special cases, if you have sine squared and you have cos squared, we can use our half angle identities to rewrite them. Okay, any questions on these two? So that's 3 and 4. Any questions on that? Okay, last one for today. What happens if sine is to an even power, but greater than 2? So this was a special case when it's 2. What happens if it's more than 2? So we'll look at that. Number 5, the integral of sine to the 4x dx. Okay, so it's still even, but now it's more than 2. So we can't use the method from before. We have to do a bit more work. So what we do, it's still even, so we're still going to use the same idea as last time, but it's a bit more complicated. So what we do is we write this as the integral of sine squared x. We know how to do that, all of that squared. Okay, so I just separated out the squared like that. Why? Because this inside part, we know how to deal with that. This is going to be the integral of 1/2 1 minus cos 2x. We've just seen that. But all of this is squared. Okay, so we need to try and handle that now. Okay, so the 1/2 squared we can take out. That's going to be 1/4. And we're left with the integral of 1 minus cos 2x, all of that squared. So that's going to be 1 minus 2 cos squared 2x plus, cos 2x plus cos squared 2x dx. Okay. Now, we can do the first term, integrating 1. That's easy. Integrating cos 2x, that's easy. What about cos squared 2x? We don't know how to do that, but we do, because remember, cos squared x we can handle by using this half angle formula. So let's just use the half angle formula again. So this cos squared 2x is going to become 1/2 1 plus cos 4x. Yeah, because the angle inside was 2x, when we use the formula, that angle gets doubled, like we have over here. The x becomes a 2x. So over here, the 2x becomes a 4x. Okay, same idea. So let's rewrite this. So this is going to be 1/4 integral of 1 minus 2 cos 2x plus 1/2 plus 1/2 cos 4x dx. Okay, so this is going to become 1/4 integral of 1 plus 1/2. That's going to be 3/2 minus 2 cos 2x plus 1/2 cos 4x dx. So that will be 1/4 3/2x minus sine 2x plus 1/8 sine 4x plus c. Okay, so you see it's not too bad. Just remember your trig identities. So over here, if you see this term, anything with cos squared, whenever that comes up, remember your half angle identity. Okay, so whenever the cos squared pops up in your integrals, you know right away, rewrite it in terms of the half angle identity. Whenever you see sine squared pop up, you rewrite that using your half angle identity. Okay, so that is the various cases for sine and cosine. If sine is odd, so we have an odd power of sine, you know how to deal with that. If you have an odd power of cos, you know how to deal with that. If sine and cos have even powers, you know how to deal with that. Okay, so that's all the possible cases for sine and cosine. Okay, and then there's just one more thing. So this was when sine and cosine were separately having even powers. What happens if they are both even? Okay, that's the last case, both even. Just remember that sine 2x is equal to 2 sine x cos x. So 1/2 sine 2x is equal to sine x cos x. Now you can take this and you can square it if you want to. You can raise it to the 4th power and so on. Okay, so that's what you do if they're both even. Okay, so that's it for today. I will upload the homework shortly on the WhatsApp group. If you have any questions, please just let me know. Yeah, I'll see you tomorrow where we will go over tan and sec integrals. Okay, bye everyone.